Number 14. Let's write the function. 3 times x plus 2 times x plus 5 squared. So find the zeros for the polynomial function and to give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. So 0, finding the zero is the same thing as finding the x-intercept, or finding the solutions of a quadratic function or of a polynomial. These are interchangeable kind of terms. So if this problem were asking us to find the x-intercept or asking us to find the zeros, we would essentially be doing the same thing. Set this function equal to 0 and determine which x values do that. Solve for x. So the zero product property says if 3 times x plus 2 times x plus 5 squared is 0, then either 3 equals 0, x plus 2 equals 0, or x plus 5 squared equals 0. For multiplying and getting 0, something has to equal 0. We know 3 can never equal 0, so that's out. But x plus 2 can be 0 if x equals negative 2. X plus 5 squared can equal 0 if x plus 5 equals 0. Right? Because 0 squared is 0. So if x equals negative 5, negative 5 plus 5 is 0. 0 squared is 0. So I've got two zeros here. So I found my zeros. X equals negative 2. X equals negative 5. Those are my zeros. Those are my x-intercepts if I'm thinking about graphing. Those are the solutions when this function equals 0. All right, so there's my zeros. Cool. I've got part of this problem done. I might be able to check and see. Yeah. All right. So negative 2, negative 5. Those are my zeros. Now let's determine the multiplicity of each zero. The multiplicity. So to do that, we have to look at the factors that gave us that 0. The factors in this original function. So this x equals negative 2, right? That came from this x plus 2 factor. This x equals negative 2, that came from this x plus 2 factor. And the power that's raised to is the first power. So the multiplicity is 1. Think about it this way. If I was to rewrite this, f of x equals 3 times x plus 2 times x plus 5 times x plus 5. How many times do I see that factor that gave us the 0? Here, x plus 2, I only see that factor once. That x equals negative 5 that came from the x plus 5 factor, I see that factor in my original function twice. Or it's raised to the second power. That's the multiplicity. How many times are you multiplying that factor that gives you the 0? Yeah? All right, so I found the zeros, found the multiplicities of each 0. Now, we need to determine if the graph of the function touches or crosses the axis at the 0. To do that, I look at the multiplicities. 1 is odd, 2 is even. Odd multiplicity means the graph crosses at the axis. Even multiplicity means the graph touches at the axis, at the x-axis at the 0, I should say. Odd multiplicity crosses the axis. Even multiplicity, the graph touches the axis at the 0. We're talking about behavior at the 0, right? So negative 2, at that 0, the multiplicity is 1, crosses the axis. At x equals negative 5, that's my 0. Multiplicity is 2, touches the axis. Let's see, which choice is that? I don't have 2 as a multiplicity, that's out. I don't have 2 as a multiplicity. So negative 2 multiplicity 1 crosses. Negative 5 multiplicity 2 just touches the axis and turns around. I think that's the one. Choice B. Take a look. Negative 2 multiplicity 1 crosses. Negative 5 multiplicity 2 touches.